All right, let's jump right into this. Welcome to this explainer, where we're embarking on a journey deep into the Ara constellation to witness what is basically an epic cosmic battle. Located about 4,000 light years away from Earth, there's this incredibly dynamic and, frankly, violent region of space that astronomers are just absolutely fascinated by. We're going to explore this massive celestial structure together, break down the unbelievable physical forces that are powering it, and see how destruction on a galactic scale is actually the ultimate engine for creation. Let's get started.
I mean, you can't deny the sheer visual majesty of NGC 1688, right? It's affectionately and, let's be honest, perfectly known as the fighting dragons of Ara. You've got these swirling, intensely dark molecular dust lanes that are so intricately woven into the glowing pink gas. They literally look like massive, mythical beasts locked in combat across the cosmos. But, this isn't just a pretty picture to hang on a wall. This represents a highly active, incredibly energetic boundary layer in space. This celestial structure demands our attention because it is actively being sculpted right before our very eyes by these invisible, overwhelming forces.
Section 1. The Dragons of Ara. So, what exactly makes up the dragons in this region of space?
Well, the dragons are what we call an emission nebula. Now, they aren't just reflecting light from something else, they are actively glowing with their own light. It's kind of like a giant cosmic neon sign. This massive cloud is being blasted by such intense high-energy radiation from nearby massive stars that the gas itself becomes ionized, which gives off that absolutely stunning pinkish-red glow. But for a nebula to glow this brightly, it requires a monumental power source nearby.
But before we meet that power source, consider the sheer scale of the distance we're dealing with here, 4,000. This entire complex sits 4,000 light years away from Earth, meaning when we look at the fighting dragons, we are literally looking at light that left that region 4,000 years ago. And despite that immense distance, these structures are so unbelievably large, and the light is so incredibly intense that we can study the minute details of the gas and dust right from our telescopes here on Earth. That profound sense of scale really sets the stage for the powerhouse that runs this whole shebang.
Section 2. Caldwell 82. The engine. Because, as we know, every glowing nebula needs an active, energetic force driving it. Take a look at the cluster dominating the space just to the east of the bright rim. That right there is the open cluster NGC 6193, also known as Caldwell 82. It is the undeniable beating heart of this region. At the very center of Caldwell 82, you have two exceptionally massive O-type stars, designated as HD 150135 and HD 150136. Now, these aren't your average everyday stars. They are absolute titans, millions of years young, and they are the primary ionizing sources responsible for lighting up the dragons. To really understand how they function as a cosmic engine, we have to look at their output. These O-type stars are some of the most massive and hottest stars in the entire universe. And because they're so insanely hot, they don't just emit visible light, they are pumping out a brutal, relentless torrent of intense ultraviolet radiation. On top of that, they generate incredibly powerful stellar winds. We're talking streams of charged particles moving at millions of miles per hour. This engine is basically acting like a cosmic blowtorch, blasting radiation and winds outward into the void and slamming directly into the dense, dark molecular clouds of the dragons.
Section 3. Sculpting the bright rim. This is not a peaceful coexistence. It's a dramatic physics experiment playing out on a galactic scale.
This is where things get really cool. If you compare the mapped carbon monoxide emission regions, which is invisible to our eyes, to the glowing, optically visible rim, it reveals something incredible. Notice how perfectly the contours of that invisible molecular gas match the glowing, sculpted edge of the rim. It's a perfect fit. This visually proves the relationship. Caldwell 82 is sitting over there to the east, just blasting the western dark cloud. The bright rim we see is exactly the interface layer where that intense radiation is violently crashing into the dense molecular material.
And, the volume of material here is staggering. 1.4 times 10 to the fourth power. That is 14,000 solar masses of molecular gas in the Ara OB1 region related to this complex. Just imagine 14,000 times the mass of our own sun existing as this massive, dark, dense wall of cold gas and dust. This is the raw material being hit, heated, and eroded every single second by the brutal stellar engine of Caldwell 82.
So how does this abstract concept of photoionization actually sculpt the gas? Well, it happens in a pretty brutal step-by-step erosion process.
First, the intense UV radiation and stellar winds from those O-type stars hit the dense wall of the molecular clouds. Second, as this energy strikes the cloud, the outer layers of the cold dust and gas are instantly heated. They literally boil off into space in a process called photoevaporation, and the gas becomes ionized. And finally, this highly energetic interaction sculpts the sharp, glowing bright rim that we actually see as the fighting dragons. The radiation is essentially carving the nebula, eating away at the dark cloud and leaving that glowing edge behind.
Section 4. Triggered star formation. Because out there in the universe, violent destruction almost always paves the way for creation. Tucked away, deeply embedded within the dark, uneroded dust, safely behind the bright rim, is a young cluster known as RC108IR. What astronomers have discovered hiding in there is absolutely fascinating. The brutal erosion and compression from Caldwell 82's winds aren't just destroying the molecular cloud, they are actively squeezing the gas inside it. It's like a giant vice. This immense pressure forces the cold gas to collapse in on itself, triggering the birth of a brand new, highly compact cluster of young protostars hidden right there in the dark dust.
The dramatic tension in this region is perfectly captured by this contrast. On one side, you have the cosmic engine itself, Caldwell 82. These are exposed, incredibly massive, blazing hot, ionizing O-type stars that are completely dominating the space. And then on the other side, literally right next door, you have RCW108IR. These are the descendants. They are embedded, currently forming protostars, shrouded completely in dense dust. The intense heat and destruction of those exposed stars is directly responsible for incubating the cold, hidden next generation.
Actually, let me just read you this quote directly from the researchers because it hits the nail on the head. They note, "The emission in the open cluster is radiation bounded by the molecular cloud containing the embedded cluster, one of the clearest examples of triggered star formation in the sky." That is incredible, right? The astronomical community looks at the fighting dragons of Arnal not just as a beautiful structure, but as a perfect textbook laboratory, proving that the death and violent radiation of one stellar generation directly forces the birth of the next. Which really leaves us with this final, beautiful thought. How is the violent destruction of the dragon's molecular clouds the exact catalyst required to birth the universe's next generation of stars? It reminds us of the beautifully cyclical nature of our cosmos. Because think about it, without the brutal, erosive radiation of Caldwell 82 acting as an engine, the cold dust of the dragons would just sit there in the dark forever. It is the friction, the battle, the literal destruction itself that sparks the light of entirely new worlds. I hope this explainer has left you as fascinated by the Roja constellation as I am, and totally eager to keep looking up to see what other cosmic engines are out there, quietly building the universe.